Hello students, friends, colleagues, and programming learners, intro to programming learners. I'm going to talk about looping control structure. I'm Dr. Satish Singhal, PhD at Rose State College, Information Technology Department in Midwest City near Oklahoma City. Okay, so we want to give introduction to loop and basically introduction to some concept of loops and various parts of a loop. And then we show some pseudocode and flowchart examples. We talk about infinite loops, and we're going to do some JavaScript code today for count control loop. Count control loops are the one that we know in advance, like how many times it's going to run. All right. So why use loops? Okay. Well, the thing is that computers are very efficient in tasks where a set of actions are to be taken repeatedly. Efficiency is where computers shine. So when some task is to be done repeatedly, then looping control structure is used. As you know from the past, if selection had to be made between one or more choices, then we use the if and else. But if we need to just repeat certain tasks, then we use something called looping control structure. And as I said earlier, computers repeat a task very efficiently, but this is the gotcha right here, provided they have been taught to do that task once correctly, which means the code that will go inside the loop has to be correct, otherwise computer will end up doing the wrong task efficiently. Okay. And that's where most programmers make errors. They don't teach computers to do a task correctly, and then they put that task into a loop and they hope that it will do it correctly, but it doesn't. Okay. We'll show some example of that. Okay. So another way of looking at loop is keep doing a task as long as certain condition is true. So we'll show some real life example of that. While you continue to be hungry, take another bite of food. This is a food eating loop. While there are unread pages, remain in the reading assignment, read another unread page. While quantity in an inventory remains low, continue to order items. And low means lower than certain threshold. While still have energy, do one more push-up. So notice this word while is used. Some condition is stated, some task is done. Okay. So these are some of the examples of loop from real life. And obviously, if hunger level is 0, you will not be continue to be hungry. So hunger level is tested here somewhere before the loop. In that case, this condition will be false and you don't enter the loop even once. This kind of loop is called a pretest loop, and that's one of the characteristics of pretest loop. It may not even execute once. Okay, this is the flowchart, generic flowchart. We test certain condition P. If the condition is true, then we do a group of tasks or statements called Q. But at some point when condition P is false, then we exit the loop. And this is the generic pseudocode, while P, do Q, and while. And Q could be one program statement or more. And in a minute we'll see more detailed version of this generic flowchart. So the flowchart and the generic pseudocode, while P, Q, this is the task and the update, and the end while. Okay, so while loop and other loops have 4 parts, And while is one of the loop, by the way. The word while is actually in the pseudocode and in the source code. Flowchart just has the diamond structure that we use in if and else. Same diamond structure, except it is in a different kind of environment actually. Okay. So there are 4 parts. One is initialization of the loop condition. For example, in food eating loop, one would start out with some initial hunger level, and of course that could be 0. That means you won't enter the loop. If it is non-zero, hunger level is some value, then you will enter the loop. And test the loop condition at the entry point of the loop. This is shown in this previous flowchart also. We are testing this condition P, and notice that anytime you test a Boolean condition, it will result into either true or false. Okay. If this test results in true, then loop is entered, otherwise it's not entered, as we saw here, that we test the condition P. If this is true, then this is the loop, task, or update, or both. But if this is false, then we exit the loop right there. Okay. And if test results in true, false very first time, loop will not be entered. Okay. At all. If the loop is entered, then there are program statements that do loop task. We'll see them very soon. And then finally, somewhere in the loop body, there is an update of loop condition suitably located in the loop body. And this is the part, update of the loop condition, people forget to do more often. And we'll show you disasters that can happen when we do that. Okay. Okay, we'll look at athlete push-up example in more detail. Suppose an athlete is doing push-ups. Before each push-up, he or she asks question implicitly, do I have energy to do next push-up? If answer is true, then they will do the next push-up. If answer is false, then they will exit the push-up loop. And we can kind of think about this kind of flow chart. Enough energy to push up, true, do next push-up. Obviously this is going to change energy level. So question asks again, enough energy to do another push-up. If that's true, do another. At some point doing this will reduce energy level so much that answer to this will be false, and then we exit the push-up loop. Okay. But once again, if answer to this is that, hey, I don't have enough energy to do even one push-up, then push-ups will not be done, so loop is not even entered. So loop task will not be done even once. And once again, that's the characteristic of loop, where we test an entry condition. And the name for that is also pre-test loop. Okay. So kind of loop where loop condition is tested up front is called a pre-test loop. And pre-test loop tests an entry condition. Okay, once again, we're going to show these 4 parts of the loop. Somewhere before the loop body even begins, we initialize the loop condition. Then we test it or pre-test. We test whether it's true or false. If this is true, we take some actions in the loop. And then we update the loop condition. So initialization, pre-test, loop task, and update. Update may keep loop condition true or may render it false. If it renders false, then we exit the loop. Otherwise, we stay in the loop like this. By the way, this diagram was done by Professor Forazon. He is a professor of computer science at Dianza College in California. And I thank you very much for him doing that. Okay, so 4 parts to the loop. This is very important when you design the loop. That loop condition is initialized. Test is put into place, loop tasks are coded, update of loop condition is done. Generally, as I mentioned, these 3, this one, and this one is not a problem. People forget to do this, and that causes infinite loops. Okay. Okay, so we're going to do a program using loops. Let's say we need to print Happy Halloween 10 times. And once again, this kind of loop is called a count control loop because we know in advance as to how many times the loop body will execute. In this case, loop body will execute 10 times. So initialization of loop condition is to set a counter to count to some initial value, for example 0, and that'll keep track of as to how many times we have printed during the loop execution in different part of the looping process. And then compare counter value at loop entry point with 10 because we should stop when we reach 10 prints. Okay, so this is kind of analysis we're doing. And pseudocode will look like this. The start, count equal to 0. This is the initialization of loop condition. Max equal to 10 because we need to print 10 times. While, the word while, count is less than 10. This is the loop condition pretest. Print Happy Halloween. This is the loop task. And since we printed already once, we need to count that. We need to take that into count. And we say count equal to count plus 1 and end while. And actually there should be end here for the program ending, which I forgot to do. Just like there is a start, there will be end. So that's that. In fact, I could just add that right now. Although it's going to go kind of at the bottom. Okay. So not to worry about that. So it's there. This is the flow chart for the same loop. Start. We set the count to 0 and max to 10. And notice the relative values of count and max. Count is less than max. Okay. So in first loop iteration, count is 0, which is less than max. So obviously this condition is true. Count is 0, max is 10. So I'm going to enter the loop. Loop condition evaluates to true, and I print Happy Halloween, and then count is increased by 1 because I printed once. So count becomes 1 in that case from 0, and then I go back and compare 1 with 10 because count became 1 here. So 1 less than 10 is still true. So I print Happy Halloween again. Count becomes then 2. 2 less than 10 is still true. So I enter the loop third time and print Happy Halloween. And then count becomes 3. Okay. So this process of printing keeps going. And at some point count will become 9. 9 less than 10 is true. So I'll print the 10th time. And then count becomes 10, and 10 less than max, which is 10, is false. That's when we exit the loop and our program terminates. So each loop iteration, Happy Halloween, is printed once and count is increased by 1. So with for counter values 0 to 9, we will print Happy Halloween. So that is 10 values, and then count becomes 10. And when we check 10 less than 10 is false, so we exit the loop. Okay. So that's how this loop works. Now here's the important point, that imagine that I deleted this step and I just went from here like this to here. Okay. Let me see if I can, if I can get a pen to do this. Pen color red. Sometimes on Mac these colors don't show up. Okay, thank God it's showing up this time. So if I discard this step here, my loop becomes like this. Well, notice count was 0, max is 10, 0 less than max is true, and count is never updated because I deleted this step. So count will be always 0 because it's never increased, So 0 less than 10 will always be true, and this loop will actually print happy Halloween infinite times. Of course, when you do it on the web, your web browser will stop the script from running after a certain time. But if you are printing that to your hard drive, well, your hard drive will get filled. So infinite loop can do some very crazy things. So if you remove update like I just did here, you'll end up into something called an infinite loop, which happens, but it's very important to realize that and correct it. Okay, so I'm gonna go to the next slide next time, but today I'm going to just take the pseudocode that we did earlier and code that into JavaScript. So let me get to my pseudocode, and I think it's better if I just do yes and show and just go to my pseudocode over here. So I'm going to be looking at that and do the JavaScript now. For JavaScript, I'm going to go to my drive here and copy the JavaScript file. So let's go here. Yeah, computer is a little slow when we make videos, so that's the reason actually. But it'll work. Okay, so okay, so looks like I don't have that. Well, that's okay. I'll just adopt this one, copy, paste, and I'll just change the name here. To count control loop. And open with Text Wrangler since I'm working on the Mac. Okay, it's going to come up. There you go. And I'm going to delete the code inside, which is from the previous program. Actually, I'm going to keep one variable. Just delete all. Excuse me. Just delete all this, but keep the BR. Okay, so let's look at our pseudocode and then iterate back and forth between the JavaScript code. So I need to declare these two variables, count and max. So var count equal to 0, var max equal to 10. So I've done that much. This part is same in JavaScript and the pseudocode, while count is less than max, and this here should have been max because I already defined a variable for that. Left curly brace. Print in JavaScript is document dot write ln happy Halloween, and plus the line break, so they all come out on different lines. Okay, and then count equal to count plus 1 and close the brace. So you don't really need for anything from end while. Just closing of the brace will work. And I'll save my file. Okay, Command S should save it on JavaScript. And then I go back to my folder where I have it, to this one, and right click and open with, and I want to open it with Firefox. And there you go. It printed 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright. So that's the count control loop. Once more, I'm going to show you in JavaScript. This was the initialization of loop condition, because later on we are comparing count with something else. This is my pretest, because this will result in a Boolean value. This is my loop task, and this is my loop update. So all four things that I mentioned in one of the PowerPoint earlier, initialization, pretest, loop task, and update, those are present. Okay, and it's very important that you remember at least the update for sure. Other things will, I think, will just come out in wash, but that's where people make error. They forget to do the update, and I'm going to demo that. I don't know how it's going to go. So this was the update, so I'm going to comment out the update. Okay, and I just save the file, and I think I already have the web page, so I will reload the web page, and you'll see some crazy things happening. First, of course, nothing happens. Now computer is busy doing something because it can't really understand that we have an infinite loop. And okay, still working. It's trying to interpret the code that's causing it so much problem. But sooner or later it will tell me that this script cannot be run. And okay, well, yeah, this wheel will keep spinning. Basically it's just running through that infinite loop. Okay, we'll wait another 30 seconds. When I did in the class, it just did Happy Halloween, like, okay, there you go. Unresponsive script. The script on this page may be busy, but basically it's saying that it's an infinite loop. So no point continuing it. I'll stop the script. Okay. So that's what infinite loop does to scripts in JavaScript. Has other behaviors in other systems. Okay. So hopefully that'll work. Now I just want to go back and just talk in general about loops, looping control structure. Loops are more frequent than you will realize or give them credit for. Every video game you play has a loop, game loop in it. Okay? Until you end the video game, the game loop keeps running. Every embedded systems are computers that are embedded into devices. Other things. Embedded system is there in your calculator, in your refrigerator, in your washing machine, in your kitchen range, in your dishwasher, in your TV, in your DVD player, and lots of them are in your car or any other device. Even lawnmowers have them today. In fact, number of embedded computers, which is as opposed to non-embedded. Non-embedded is something like your computer, your laptop, your tablet and all that. Number of embedded computer has surpassed non-embedded by millions, actually, maybe even more than that. And every embedded computer has a loop inside them, because it's supposed to do something again and again and again. So looping is a lot more common than you think. Okay, so today I will be finishing here. Basically, I can give you concepts of the loop. I told you most importantly the 4 parts of a loop. Emphasize that if you skip update, you'll end up with the infinite loop, which will have non-responsive program basically. Did the pseudocode and the flowchart for printing Happy Halloween 10 times. That was a count control loop where we knew in advance how many times loop will run, and so on. So in this slide, PowerPoint and source code is available from me. And I'll come back to do more of these for JavaScript soon. Thank you.